Alright, so chapter 7 is Rollercoaster. Alright, here we go. So we've transferred everything. You got this?
No.
Cause I went on and converted 17 miles per hour.
Mm-hmm.
I'm looking for meters per second.
Right.
So let's start with miles. 1 mile is 1 kilometer is 0.6 miles. So if I have miles on top, I want to put miles on the bottom,
Okay.
and then I'm saying that's 1 kilometer.
Okay.
So I think that's the part that you were thinking about, that you were wondering about.
Yeah.
So and then I have hours. Well, next would be meters. Changing my kilometer to meters. So 1,000 meters is in 1 kilometer, so that I can cancel out kilometers. Kilometers canceled out. Miles canceled out. Alright, so now I'm left with hours. I need to change my hours to seconds. And we know that's 60 minutes and then 60 seconds. So that's 3,600 seconds, which we just did that here. It's the same thing, 60 and 60. Alright, boom. So I got 7.87. Alright, so now we have everything we need. We have all our knowns. Unknowns figured out. Yeah, so let's go ahead and put them in.
Well, no, we ain't got nothing.
And then, so we'll see how the, all right, so MGH. So let's go ahead and plug in M, my mass, 1 kilogram, gravity, yeah, and now height. So this is the potential energy. So we'll use the height. We'll use the height that's at the top, which is the top height, which we know initial height is 0. So this elevation change, we put it here. Maximum height.
What you want, the one on the top? Go back to the picture. I need to see it with my eyes.
Mm-hmm. See, that's why. So there's
Nothing on the screen. There's nothing up there.
Yeah. So the maximum height
Is
is that. Yeah, where it says 25 meters. That's our maximum height. But then final minus initial, the elevation change, that's this height. So this final minus initial.
Is that what
The maximum height includes this dip right here.
So 25 meters equals 305 feet. Is what you're telling me?
Yeah, so at the top,
Just want to-
right, 91.5 meters. So we did that up here.
Right.
305 feet times 0.3 meters.
I know.
91.5.
Not what I.
Oh, I think this
That's
is a
not-
totally different
That's not what I.
Yeah, it's probably.
Oh yeah, this isn't the same problem. I just put this up.
No.
What was the question?
I asked you what did 25 meters equal.
Oh,
You
where
telling
that
me
came
something
from.
different.
Oh, see, right. I was trying to explain that that same. The numbers aren't the same. But I was trying to explain that this portion is the maximum height. So our MGH, our potential energy, is going to use the maximum height. But then our final minus initial, what happens at the end of it, Wait, let's see.
Oh, we don't need
Velocity
the
at
picture, that's why I want to look at the picture, I just want to see what the number was, so I can tell you.
Mm,
They're not there, so let's
Yeah,
just go with
it's,
305,
yeah, so
91.5
we could put
meters.
the 305.
I just want to say, wow, it's so good.
1.5 meters. And then this height, H final, is 90. Alright. Potential energy, we gotta use at the top. So we're about to use 7.87 meter per second. Wait, this is the height. I'm using 91 meters.
Mm-hmm.
Plus 1/2. My mass again, 1 kilogram.
You not doing 91.5 meters? Do it matter?
Good catch. Go ahead of myself. Alright, 1 kilogram, my velocity. So what's my initial velocity?
17?
Yeah, miles per hour, which is 187 meter per second. Just trying to make it look not squared. So MGH. So what y'all get for potential energy?
Nothing yet.
96.7.
Click on me, Newtons.
Not there.
So a kg meter squared over second squared is actually a joule.
See, you know what? I ain't got the
It's a
time.
jewel.
So this is a new. So this is a new. This is another unit. So
But it is a part of the SI. It is the SI unit.
so a joule.
Joule.
All right.
You put it in our
So
chemistry. Or I
a
did.
joule is also
Just didn't know.
a Newton times meter.
Oh, okay. Oh, got you. Okay.
Okay, so Newton is the kg m over s squared
You gotta think.
times meters. If I multiply by meters, this is now in joules.
Joules.
Yeah.
Gotcha.
Joule. Joule.
Like one of my nicknames.
Well, you know how to spell something.
And joules is energy in direction.
Hmm?
Somewhat.
No, ma'am. It's the SI unit of energy. If I make it any more complicated.
Yeah, the movement. Yeah, the movement of energy. Yeah. Yeah. It's in your way.
I'm not trying to take a break yet.
It's 12 already.
So maybe we got one more time for one more, but make it.
Yeah, the next,
Serious. Aw.
some of the homework, like we could go over the
Yeah,
harder,
gotta do.
the harder one.
I don't want to do too many problems right here.
So the SI unit for work and energy is the joule. 1 joule equals Newton times meter,
What did we come up with?
which is the kg m squared over.
896.6?
So we just got potential energy.
Yeah, we didn't.
We just got MGH so far. I was just showing y'all. We were asking what is our unit gonna be? So our unit's gonna be
Joules.
joules, correct?
That makes sense.
Yeah,
That's
yeah.
fine.
See.
So 1/2 mv squared.
Start saying that.
1/2
Times.
m.
So what would that be, 1/2 times a kilogram? Would that be 1/2 times
This is half.
Yeah, it's just
kilogram.
one. Yeah, I would just do
You will multiply that first and then divide it by half.
yeah, I was about to say that. Yeah, it would be better to do this exponent.
Oh, I didn't see that.
M dots.
Just that. There you go. I was just gonna say it. Do a second parentheses
Yeah,
first.
parentheses would be 1 times 7.87, but then exponents is real important, so 7.87 squared. Well, this parentheses is important with that exponent. So anyway, let's do 7.87 squared. I get
I
61.93.
got the same thing.
Good.
61.
I didn't type it. I didn't type
Where you
it
get-
again, but I put
Where'd you put in your
everything.
calculator?
7.87 squared.
What did you put?
Oh, I just did 7.87 times 2.
What? It's so
Oh,
good.
yeah.
It says square.
Yeah, it happens.
I believe in you today, so I knew it was right.
Okay, there we go.
There you go.
That's it.
And
One
then you
divided
divide
by
it. How you do the cute little two? Go ahead.
My answer.
What are you doing?
Wait,
Why did you just divide it by 2?
Well, I could have just divided by 0.5.
You know what I mean? Yes. Whatever. Still. Divide it up for a half. Oh, you could have multiplied by what you was going to multiply. What you was going to multiply? No, I think
Oh,
you got to
times-
multiply by 0.5.
30.96. Oh, 7. Okay, yep.
You multiply by 0.5?
Yep.
Okay. No, I just want to know for my purpose, so I know what the physics can do.
That's it.
I can't Ooh, it got to be meter squared over second squared right there.
Yeah. Yeah, I'm squaring both of them, which is good because they're both in joules.
That's nice.
So now 896.
30.
So now we're adding up the two. Mechanical energy is potential energy plus kinetic energy. So now let's add up the two.
So it's 30.97 kilogram meters squared over 62.
Plus
Yep.
896.
Yeah, that's a joule.
Okay.
Plus 896.
So that means joule though. No problem.
Correct.
Can I put J or no? Not today. It needs to be like that.
Nah, J, either one is fine.
Okay.
If you put kg meter squared over second squared, that's not a problem, you know.
As long as I get mine. I'm just thinking
Units,
about mine.
putting units is important, but if you would need to put either this or joules, yeah. Because if you just put this answer right here,
That's wrong.
I don't know. I don't know if
It's gonna be
it's
units.
I don't know what
Apple,
that
It could be
is.
miles, it
It
could
could be
be,
years.
yeah.
miles.
If it's years, it's like, well, what were you doing?
you doing for that many years?
That's why it's recording. So that's 927.7. So that's the entire.
How would they know? They're never gonna know. That's it. That's the
And then we
final
would need to
answer.
do the bottom of the hill,
Oh,
which
shit.
the change in elevation is gonna be the bottom of the hill, the
See,
90
you did one.
meters. So and then we just gotta do it right here. We just need to change this to 90. Let me write it in a different color. And then we just need to change this.
So this was the top of the hill method.
Yeah, top. Bottom is 90. Bottom. And we can find the whole system. So 9.8 times 91.5. I mean 90. I get
Hey, home.
200. Hey, welcome.
Always glad to have her comer.
So and then
I don't even remember. Oh, I see.
So adding those, that's only the top, the 896 and the 30?
Yeah, the final answer, we ain't worried about that. 927.7 is for the top. The bottom one, you're gonna use the 30 though, I think, maybe. Cause he didn't change anything on the second. Yeah. Don't do the same. We just hit the plug in 90 on the first part. And so another 91.
yeah, he's right. The velocity,
Did it change?
yeah, because we have, because that was our speed on the lift.
So what's the second speed? Is it maximum speed now?
Yeah. So now we have another speed.
Okay, yeah.
Ooh,
Uh-huh.
I'm glad I didn't write that down.
Now you need to take out the,
The whole thing.
take out the
7
91.
Yeah, we changed that to 90 already. We talking about the second part of the
Why would you
question.
change it to 90?
Because he said that we need to use the other one. Remember that other one from earlier? Elevation change? That's what he said. He said 50, 90.
Oh, okay, okay.
Alright, so that's that. And then,
That's what my teacher said.
so now 1/2. Okay, so 40.28 squared.
Oh.
I get 16.22. 48 meters squared per second squared.
So it's the 40.28. Let me do both the sequence.
And then 1/2.
Y'all type that in, what we did.
This. $811 joules. Let me make that.
What you type in your calculator? This 9.8 times 91?
What did I type into?
90. What you type in your calculator?
Yeah, just 9.8 times 90. On the left side.
I didn't get that.
For the left side, I typed in 9.8 times 90.
When you get there, I got 882.
Yeah, that's this right here.
Oh, what's the electric joule from?
So
Oh, that
this
was for the
comes
upside.
from after I did 1/2
Oh, okay.
times mv squared.
Can't keep up with you. I was on the first part. 882.
So I did this bottom, much like that, and then this relates to this at the bottom. See, so this answer is the difference. This relates to this at the bottom at 82, and the new bottom. That's what that is. Well, let me not put over bottom. That's bottom. That's bottom. This is my B final. 811 is bottom. Alright, so now we have everything we need. 882 plus 811.
We did 1633.
Yeah, I did that too. 1693? You said 93. So does that make sense? Is our question now.
Yeah.
Would the mechanical energy be less at the top than at the bottom? Would that make sense?
With the mechanical energy be less at the top? Yes. Because the kinetic energy should have been smaller.
Right.
Oh, okay, yeah.
Both of them. Yeah, both of them should be smaller. So what we just did, we looked at a roller coaster going up, and the question, the video at the beginning of chapter 7, it's a roller coaster. It talks about mechanical energy. So mechanical energy is potential energy plus kinetic energy. So we're looking at the overall energy of the system. Our potential energy, mgh, kinetic energy, 1/2 mv squared. And boom. There you have it.
We broke down, changing our units,
Yes.
and then so that we can basically plug in
Yeah.
Yes.
what we have.
So we got introduced to a new unit as well, the joules,
You have fine joules?
Newton times meter.
Yeah. So you know, kilograms meters per second is newtons, right?
Yeah.
So,
Oh yeah.
um,
I'll do that.
yeah.
Yeah.
It's okay, it's okay. I'm gonna get
So
it.
this is a kilogram. This is what a kilogram.
What? Let me see.
So that's.
That's what the kilogram Yeah, what?
So
That's not heavy.
imagine this over, meter per second. So 1 Newton is 1 kilogram times
That's
meter per
fast.
second squared.
So if this is going like 60 meters per second.
Right.
So this is heavy.
Right.
Like this is really heavy. I didn't know a kilogram felt like this.
Yeah.
What? Okay, thank you.
Now it makes I went roaming around.
I'm ready to do chicken trees.
So that's 1 kilogram. I mean, half of the other one that I found is half of a kilogram. So 500 grams.
Oh, I was supposed to be in there,
So
but
this
they
is
ain't
half.
said nothing to me, so.
Half of a kilogram. That's
I
500
didn't have
grams.
too much to do, so.
So 1 unit.
I would assume so. I don't know. They said they would email me, but I have
I was
to
asking
email.
about Jules
Yeah.
because when you in
Okay.
my field, when I defibrillate somebody,
Yeah, they
it goes
okay.
back to so it'd be like 300 joules.
I did. I did.
I did.
Feel everything.
350 joules.
Right.
Can I
Probably
I don't know. I know.
Because that has to do with
they said they would do a
the
scholarship
pump,
or
the
something like that.
blood.
Kilograms,
Right,
like
because
that.
you defibrillate when your blood's not pumping, so the heart isn't moving. So that has to do with that motion, obviously. How much the blood, the mass of the blood, and then moving through the system. Oh no, that's the charge.
Okay, I'm gonna break it.
That's the charge. Yeah, because later on,
You a trio?
I'm a classic trio.
What you mean?
Like a trio spin.
Was it in the
What's that
email?
trio?
Classic trio
You
is
know what
like
it's
for your
about?
regular classes, like they help you tutor and stuff like that.
Was it in the email?
Trio stuff is like for biology.
For STEM.
Sim.
Oh, okay. I think I'm in that one.
Made,
Yes, yeah.
mathematics,
Yeah.
whatever.
yeah, see here it is. It's also the energy dissipated as heat when an electric current of 1 ampere passes through a resistance of 1 ohm for 1 second.
Put no line.
It's named after the English physicist James Prescott Joule.
Anyway. No, we're gonna go there.
So not only is it the amount of work done when a force of 1 Newton displaces a mass through a distance, which we saw through the roller coaster, but it's also the electric current, the energy from an electric current.
You got taxi charger? I didn't charge my pen. I'm so like, I looked at my regular pen and I should grab it.
No, I didn't bring any of my chargers. You know, I
Okay,
left
I'm
them.
gonna have somebody.
Let me see if I have my portable
Oh, there's a half
charger.
a kilogram.
Oh,
Is this it right here?
Oh,
correct. Yes.
this what you need?
I need that too. My phone is dead. Oh, this is wonderful. This can connect to my iPad. Thank you. Okay, this is how I thought a kilogram would feel though.
Yeah, me too.
Yeah. So let's see the speed of a bullet. Speed of a bullet. A rifle bullet travels around 2,700 miles per hour.
See, bro, dang. Way more than I thought.
2,700
What the world?
feet per second, which is around 3,000 kilometers per hour. So the speed of a 1 kilogram bullet, or like some ballistics.
Oh, I was kind of close. I said 60.
Yeah, that was good. That was a good, depending on the firearm cartridge. A 1 kilogram bullet is extremely heavy.
Damn, hurt. I'm glad you brought this gun. I need to know.
With masses. Yeah. I was roaming around the back, looking at different things to strengthen our understanding. Next, I want to do some spring. So, and then we have the homework.